Hello, in this lecture we'll find out the radius of the semicircle. In the drawing we have a semicircle. We also know that PA, line segment PA equals to 6 units in its length, and PA is tangent to this semicircle at point A, and PQ equals to 4 units in its length. Line segment PQ equals to 4 units in its length, and line segment PS cuts the semicircle at points Q and S. And we also know that QS equals to QC, and this angle PAB equals to 90 degrees, and this is angle SQC that is also equals to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. Okay, so first of all I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 10. According to rule number 10, in any circle, if AB is any chord in the circle and PT is tangent to the circle, then the following equation is true. Here, tangent PT is tangent to this circle at point T. AB is a chord in this circle, and the line segment PB cuts the circle at points A and B. So here the following equation is true, that PT square equals to PA times P. Again, PT square equals to PA times PB. We can actually implement the new rule in our drawing. Why? Because in our drawing, if you focus on at point P, from point P we have tangent PA that is tangent to the semicircle at point A, and we have also here line segment PS that cuts the circle at points Q and S. Therefore, we can implement here rule number 10. And according to rule number 10, PA squared equals to PQ times PS. Repeat again. If you focus at point P, according to rule number 10, we'll get that PA square equals to PQ times PS. PA is 6, therefore PA square is 6 square, that is 36. That is equals to PQ is 4 times PS. PS is 4 plus QS. So in conclusion, we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we divide this equation by 4, and finally we get that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtract 4 from this equation, and we get that finally that QS equals to 9 minus 4, that is 5. So QS equals to 5 units in its length. You can write down in the original drawing that QS, this called QS, equals to 5 units in its length. But it is given us the question that QS equals to QC. And QS is 5, therefore QC must be also equal to 5 units in its length. In the next step, we'll implement rule number 3 on the straight line PS. PS is a straight line, so if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees. Repeat on rule number 3 again. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. AB is a straight line, so if we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have angle alpha and beta. Therefore, according to rule number 3, alpha plus beta must be equal to 180 degrees. We can actually implement rule number 3 in our drawing, because if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have here? At the lower side of PS at point Q, we have this angle that is equal to 90 degrees, plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles at the lower side of PS at point Q to 180 degrees, here the missing angle must be equal to 90 degrees. According to rule number 3, of course. We join points P and C together by a straight line. By joining points P and C, we created the right triangle, triangle PQC. So I copied the right triangle PQC in a new page, and we will implement on this right triangle, triangle PQC, the Pythagoras theorem. By PT is the abbreviation for Pythagoras theorem. Side PQ equals to 4 units in its length. We just right now found out that side QC equals to 5 units in its length. So actually, this is the right angle PQC that they covered from the original drawing. According to the Pythagoras theorem, in this right angle triangle PQC, we get that PC squared, that is the square of the hypotenuse, equals to PQ squared plus QC squared. So PC squared equals to PQ squared. PQ is 4, therefore PQ squared is 4 squared, that is 16, plus QC squared. QC is 5, therefore QC squared is 5 squared, that is 25. So in total, PC squared equals to 16 plus 25, that is 41. Finally, we found out that PC squared equals to 41. PC squared equals to 41. In the next step, I will copy the right triangle, triangle PAC in a new page, and we will implement on this right triangle PAC the Pythagoras theorem. Side PA equals to 6 units according to what is given as the question. And we already found out that PC squared equals to 41. we define the length of side AC as A. So actually, this is the right triangle PAC that I copied from the original drawing. PA equals to 6 and AC equals to A according to our definition. PC squared equals to 41 according to what we have already found out. So in the right triangle PAC by PT's abbreviation for Pythagoras theorem, we will get that PC squared equals to PA squared plus AC squared. PC squared is 41 and it is equal to PA squared. PA is 6, therefore PA squared is 6 squared, that is 36, plus AC squared. AC is A, according to our definition, so AC squared is A squared. So conclusion found out that 41 equals to 36 plus A squared. Here we'll subtract 36 from this equation, and finally we get that A squared equals to 41 minus 36 is 5. Here we take a root out of this equation, and finally we get that A equals to the square root of 5 units. So we can write here that line segment AC or side AC equals to A, and A equals to the square root of 5 units. Okay? Because of the fact that this is a semicircle, AB must be the diameter of the semicircle. I'll write it down here. AB is the diameter of the semicircle. So if we define the radius of the semicircle as x, then the diameter AB must be equal to 2x. Okay, so here the diameter AB equals to 2x. So what is the length of side CB? From the drawing it is very easy to see that CB equals to AB minus AC. AB is 2x, AC is equal to 5, so total CB equals to 2x minus square root of 5. So write it down here. The length of side CB equals to 2x minus square root of 5. Okay. In the next step, we will complete the semicircle to a circle. Completed the semicircle to a circle, and we will extend side QC by straight line until it touches the circle. And we will define the touching point of the extended side QC with this circle as M. We will define the length of line segment CM here. We define the length of this line segment CM as B. Okay, so in the next step, I will present to you a new rule, and we'll implement the new rule in our drawing. Here we have actually rule number 11. According to rule number 11, in any circle, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times BO equals to CO times DO. So rule 11 talks about two chords that intersect with each other inside the circle. Whenever you have two chords that intersect with each other inside the circle, like in this drawing, we have chord AB that intersects with chord CD at point O. Point O is the intersection point between the two chords. Then the following equation will be true, that AO times OB equals to CO times OD. So whenever we have two chords that intersect with each other, then the following equation is true, that AO times OB equals to CO times OD. We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. So I write it down. Chord AB intersects with chord QM at point C. Because of the fact that chord AB intersects with chord QM inside this circle, we can implement it rule number 11. I'll repeat again. In our drawing, chord AB intersects with chord QM at point C. Therefore, according to rule number 11, we get that AC times CB equals to QC times CM. Repeat again. Because of the fact that in our drawing we have two chords that intersect with each other, we can implement here rule number 11. According to rule number 11, we'll get that AC times CB equals to QC times CM. This is equation number 1. AC is equal to 5. AC is A and A is equal to 5. So AC is equal to 5 times CB. CB equals to 2x 1 is equal to 5. And it is equals to QC. QC is 5 times CM. According to our definition, the length of line segment CM is B. So it is B. In conclusion, further that according to rule number 11, square root of 5 times 2x minus square root of 5 equals to 5b. Here we will divide this equation number 1 by square root of 5, and we get that according to equation number 1, two x minus square root of 5 equals to 5b over square root of 5. Repeat again. According to equation number 1, we found out that 2x minus square root of 5 equals to 5b over square root of 5. Here we will add to this equation number 1 square root of 5. And we get that according to this equation number 1, two x equals to 5b over square root of 5 plus square root of 5. So here we multiply square root of 5 by square root of 5 and then we divide it by square root of 5 in order to have a common factor with this expression. And we get that according to equation number 1, that 2x equals to 5b over square root of 5. Again, we will multiply square root of 5 by square root of 5, so it is square root of 5 times square root of 5, and then we will divide it by square root of 5, so we change nothing. So for one found out the 2x equals to 5b plus square root of 5, so it is 5b plus square root of 5 times square root of 5 is 5 over square root of 5. In conclusion, we found out that according to equation number 1, 2x equals to 5b plus 5 over square root of 5. Here we will divide this equation by 2, and finally we will get that x, it is the radius that we are looking for, x equals to 5b plus 5 over 2 times square root of 5. So we actually expresses the radius x, that is the radius that we are looking for in terms of b. So now we'll find out the value of b, and in this way we also will find out the value of x, that is the radius of the semicircle, that is the radius that we are looking for in this question, the radius of this semicircle. So in the next step we will join points M and S together by a straight line. Repeat again, we join points M and S together by a straight line. So in the drawing we have peripheral angle MQS. This is peripheral angle MQS. That is equals to 90 degrees. So I write it down here. Peripheral angle MQS equals to 90 degrees. And here we have rule number 5 that talks about a peripheral angle that is equals to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees. Therefore, according to this rule, rule number 5, this peripheral angle MAN must rest on the diameter of the circle. Peripheral angle MAN rests on MN, therefore MN is the diameter of the circle. You can implement rule number 5 in our drawing. Because of the fact that peripheral angle MQS, this peripheral angle MQS equals to 90 degrees, according to rule number 5, it must rest on the diameter of the circle. This peripheral angle MQS rests on MS, therefore MS must be the diameter of the circle according to rule number 5. So I write it down here that according to rule number 5, MS is the diameter of the circle, of the diameter of the circle or diameter of the semicircle. It doesn't matter because we actually completed the semicircle to a circle, so the diameter of the semicircle is exactly the same of the diameter of the circle. They are identical. Okay, so MS is the diameter of the circle and also the diameter of the semicircle. If we define the radius of the semicircle as x, then x is the radius of the semicircle. according to our definition. Therefore, the diameter MS must be equal to 2x. MS equals to 2x. Okay, here the diameter MS equals to 2x. It is twice as long as the radius. In the next step, I will copy the right triangle MQS in a new page, and we will implement the Pythagoras theorem in this right triangle MQS. By PT is the abbreviation for Pythagoras theorem. Side QS equals to 5 units in its length. What is the length of QM? Here from the drawing it is very easy to see that QM equals to QC plus CM. That is to say QM equals to QC, that is 5, plus CM, that is B. So in total QM equals to 5 plus B. And the hypotenuse MS is the diameter of the circle. That is to say it is equals to 2x. So actually, this is the right triangle QSM that I copied from the original drawing. According to the Pythagoras theorem, in the right triangle QMS, SM squared equals to QS squared plus QM squared. SM equals to 2x, therefore SM squared is 2x squared. And it is equals to QS squared. QS is 5, therefore QS squared is 5 squared, that is 25, plus QM squared. QM is 5 plus B, therefore QM squared is 5 plus B squared. In conclusion, found out that according to equation number 2, 2x squared equals to 25 plus 5 plus b squared. This is according to equation number 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Therefore, we can substitute x in this equation number 2, by 5b plus 5 over 2 times square root of 5. We will do it now, and we will get that according to equation number 2, 2 times x, and x is, according to equation number 1, x is 5b plus 5 over 2 times square root of 5 squared, because it is 2x squared, equals to 25 plus 5 plus b squared. So in this side of the equation we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in this side of the equation, after we cancelled 2, we left only with 5b plus 5 squared over square root of 5 squared is 5. and this equals to 25 plus 5 plus b squared. Repeat again. According to equation number 2, we found out actually that 5b plus 5 squared over 5 equals to 25 plus 5 plus b squared. So here we'll open the brackets on both sides of this equation, equation number 2, and we get that according to equation number 2, here we have 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b. All divided by 5. And the other side of the equation we have 25 plus 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b is 10b. So in this side of the equation we have 25b squared over 5 is 5b squared, plus 25 over 5 is 5, and 50b over 5 is 10b. In the other side of the equation we have 10b plus b squared, 25 plus 25 is 50, so it is plus 50. So here we have 10b on both sides of the equation, so 10b will get cancelled. After we cancel 10b, on this side of the equation we left only with 5b squared plus 5, that is equals to, on the other side of the equation we left with 50 plus b squared. Okay, so here we subtract b squared from this equation, equation number 2, and finally we get that according to equation number 2, 5b squared minus b squared is 4b squared plus 5 equals to 50. Here we subtract 5 from this equation, equation number 2, and finally we get that according to equation number 2, (4b squared) equals to 50 minus 5 is 45. 4b squared equals to 45. Here we divide this equation, equation number 2, by 4. And finally we get that according to equation number 2, b squared equals to 45 over 4. So according to equation number 2, b squared equals to 45. 45 is 9 times 5, so we substitute 45 by 9 times 5 over 4. Here we take a root out of this equation, equation number 2, and finally we will get that according to equation number 2, b equals to the square root of 9 times 5 over 4. The square root of 9 is 3 and the square root of 4 is 2. So inside the root we left only with 5. In conclusion, we found out actually that b equals to 3 times square root of 5 over 2. According to equation number 2, I'll repeat again. We also found out that according to equation number 2, b equals to 3 times square root of 5 over 2. Well, according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So now we can substitute b in this equation number 1, by 3 times square root of 5 over 2. We'll do it now, and we get that according to equation number 1, x equals to 5b. So it is 5 times b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. So actually we found out that according to equation number 1, x, it is the radius of the semicircle, that is the radius that we are looking for. It is equals to 5 times 3 is 15, so this expression in total equals to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. So here we will multiply 5 by 2 and then we divide it by 2 in order to have a common factor with this expression. And we get that according to equation number 1, x equals to 15 times square root of 5 over 2. Here we'll multiply 5 by 2, so 5 times 2 is 10. And then we divide it by 2, so we change nothing. All divided by 2 times square root of 5. Here we'll move 2 times square root of 5 to the denominator here, and we get that according to equation number 1, x equals to 15 times square root of 5 plus 10 over 2 times 2 times square root of 5. That is to say, x equals to square root of 5 times 15 plus 10 is 2 times square root of 5 times square root of 5 over 2 times 2 is 4, so this expression in total equals to 4 times square root of 5. So x equals to, we take square root of 5 as a common factor from the numerator. So what is left from square root of 5 times 15 after we took from it square root of 5 as a common factor? What is left is actually 15 plus here. What is left from square root of 5 times square root of 5 times 2 after we took from it square root of 5 as a common factor? What is left is actually 2 times square root of 5, all divided by 4 times square root of 5. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out actually x, that is the radius of the semicircle, that is the radius that we are looking for, equals to 15 plus 2 times square root of 5 over 4 units. Repeat again. We actually found out that x, that is the radius of the semicircle, that is the radius that we are looking for, equals to either 15 times square root of 5 over 4 units, or in terms of numbers, it is equals to 4.8680 units. That is the answer to the question. I repeat again. The radius x of the semicircle equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of the semicircle equals to 4.8680 units. It's a bit less than 4.9 units. Okay, so in the next step I'll summarize the lecture. So in this lecture, we found out the radius of this semicircle. It's given us the question that line segment PA equals to 6 units in its length, and PA is tangent to the semicircle at point A. We also know that PQ, line segment PQ equals to 4 units in its length, and line segment PS cuts the semicircle at points Q and S. And we also know that CQ equals to QS. This angle PAB equals to 90 degrees, and this is angle SQC that is also equals to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. Okay, so first of all, I present to you a new rule, and we implemented the new rule in our drawing. The new rule is actually rule number 10. Only to rule number 10. In any circle, if AB is a chord in the circle and PT is a tangent to the circle, here AB is a chord inside the circle and PT is tangent to this circle point T, then the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule number 10 in our drawing. Why? Because in our drawing, if we focus at point P, from point P we have tangent PA to this circle, tangent PA is tangent to the circle at point A, and we have line segment PS that cuts the circle, cuts the semicircle at points Q and S. For that reason, we can implement here rule number 10. According to rule number 10, we will get that PA square equals to PQ times PS. I'll repeat again. If we focus at point P, according to rule number 10, PA square equals to PQ times PS. PA is 6, therefore PA square is 6 squared, that is 36, and it is equal to PQ, that is 4, times PS. PS in total equals to 4 plus QS. Yeah, PS equals to 4 plus QS. So in total we found out that 36 equals to 4 times 4 plus QS. Here we divided this equation by 4, and finally found out that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtracted 4 from this equation and found out finally that QS equals to 9 minus 4, that is 5. So here QS equals to 5 units in its length. And because of the fact that according to what is given us in the equation, QS equals to QC, and QS equals to 5, therefore QC must be also equal to 5 units in its length. In the next step, we implemented rule number 3 in our drawing. If we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 90 degrees. We repeat on rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. We have the straight line AB. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have? At the upper side of AB at point Q, we have angle alpha and beta. Therefore, according to this rule, rule number 3, alpha plus beta must be equal to 180 degrees. We can implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the lower side of the straight, if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total they must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees. And therefore triangle PQC is a right angle. So I copy the right angle PQC In the new page, we implemented the Pythagoras theorem in this right triangle, triangle PQC. Actually, this is the right triangle, triangle PQC that they call it from the original drawing. PQ equals to 4 units according to what is given in the question. We just right now found out that QC equals to 5. By PT is a version for Pythagoras theorem, so according to the Pythagoras theorem in this right triangle PQC, we will get that PC square equals to PQ square plus QC square. So PC square equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 squared, that is 25. So in conclusion, we found out that PC square equals to 16 plus 25, that is 41. So PC square equals to 41 units. Then I copied the right triangle PAC in the new page and we implemented the Pythagoras theorem in this right triangle PAC. Actually, this is the right triangle PAC that I copied from the original domain. PA equals to 6 units. PA equals to 6 units according to what is given us in the question. We define the length of side AC as A, and we already found out that PC square equals to 41. Here by PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle PAC, we'll get that PC square equals to PA square plus AC square. So PC square is 41, and it is equal to PA square. PA is 6, therefore PA square is 6 squared, that is 36. Plus AC square. AC is A according to our definition, therefore AC square is A square. So in total we found out actually that 41 equals to 36 plus A square. Here we subtracted 36 from this equation and finally found out that A square equals to 41 minus 36, that is 5. So A square equals to 5. We took a root out of this equation and finally found out that A equals to the square root of 5 units. Here A equals to the square root of 5 units. So the length of line segment AC is A, and A equals to the square root of 5 units. Then we found out the length of line segment CB from the drawing. It is very easy to see that CB equals to AB minus AC. That is to say CB equals to AB, that is 2x, because AB is the diameter of the circle, minus AC, that is square root of 5. So in total CB equals to 2x times square root of 5. Repeat again, AB is the diameter of the circle because of the fact that this is a semicircle, therefore AB must be the diameter of the circle. So we found out that CB equals to 2x times square root of 5 because x is the radius. Then we completed the semicircle to a circle and we extended side QC by straight line until it touches the circle. We define the touching point of the extended side QC with this circle as M. And then I presented to you rule number 11 and we implemented rule number 11 in our drawing. According to rule number 11, rule number 11 talks about two chords that intersect with each other in a circle. Here, if chord AB intersects with chord CD at point O. Whenever you have two chords that intersect with each other, then the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Repeat again. In our drawing we have chord AB that intersects with chord QM at point C. Therefore, according to rule number 11, we get that AC times CB equals to QC times CM. Repeat again. Here we define CM as B. Repeat again. According to rule number 11, AC times CB equals to QC times CM. AC is equal to 5. AC is A and A is equal to 5. CB is 2x minus equal to 5. QC is 5 and CM equals to B according to our definition. So in conclusion, we found out that according to equation number 1, square root of 5 times 2x minus square root of 5 equals to 5b. Here we divided this equation number 1 by square root of 5, and finally found out that according to equation number 1, two x minus square root of 5 equals to 5b over square root of 5. Here we added to this equation number 1 square root of 5, and finally we found out that 2x equals to 5b over square root of 5 plus square root of 5. Then we multiplied square root of 5 by square root of 5, and then we divided by square root of 5 in order to have a common factor in this expression. So finally we found out that 2x equals to 5b over square root of 5, and then here we multiplied square root of 5 by square root of 5, and then we divided by square root of 5, so we changed nothing. So actually found out that 2x equals to, in the numerator we have 5b plus square root of 5 plus square root of 5 is 5. So in total, in the numerator we have 5b plus 5 over square root of 5. So actually we found out that 2x equals to 5b plus 5 over square root of 5. Here we divided this equation number 1 by 2, and finally we found out that x equals to 5b plus 5 over 2 times square root of 5. Okay, this is according to equation number 1. Then we joined points S, M, and M together by a straight line. In the drawing we have peripheral angle MQS that is equal to 90 degrees. And according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle MAN that is equal to 90 degrees, therefore this peripheral angle must rest on the diameter of the circle. Peripheral angle MAN rests on MN, therefore MN must be the diameter of the circle. We can implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS that is equal to 90 degrees, therefore according to rule number 5, it must rest on the diameter of the circle. Peripheral angle MQS rests on MS, therefore MS must be the diameter of the circle according to rule number 5. I repeat again, because of the fact that peripheral angle MQS equals to 90 degrees, therefore according to rule number 5, it must rest on the diameter of the circle. It rests on MS, therefore MS must be the diameter of the circle. We define the radius as x, therefore the diameter MS must be equal to 2x. Okay. Repeat again, the diameter SM equals to 2x, QS equals to 5, and QM in total equals to 5 plus b. So copy the right angle QMS in the new page and implemented the Pythagoras theorem in this right angle triangle QMS. this is the right triangle QMS that I copied from the original domain. The diameter SM is 2x. Actually, the hypotenuse SM is the diameter of the circle, that is 2x. Side QS equals to 5 when it's in its length, and we just right now found out that QM equals to 5 plus B. So in this right triangle QMS, according to the Pythagoras theorem, we get that SM square equals to QS square plus QM square. SM is 2x, therefore SM square is 2x square, and it is equals to QS square. QS is 5, therefore QS square is 5 square, that is 25, plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. In conclusion, found out that according to equation number 2, 2x square equals to 25 plus 5 plus B square. This is according to equation number 2, while according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times 4 to 5. Therefore, we can actually, here we can actually substitute x in this equation number 2 by 5b plus 5 over 2 times 4 to 5. We did it. So in equation number 2 we have 2x squared. So it is 2 and x is 5b plus 5 over 2 times 4 to 5 squared. And according to equation number 2, 2x squared equals to 25 plus 5 plus b squared. So in this side of the equation number 2 we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in this side of the equation we left only with 5b plus 5 square over square root of 5 square. Square root of 5 square is 5. So in this side of the equation we left with 5b plus 5 square over 5. That is equals to 25 plus 5 plus b square. We open the brackets on both sides of the equation. 5b plus 5 square equals to 5b square, that is 25b square, plus 5 square, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b. All divided by 5. In the other side of the equation we have 25 plus 5 plus b square. 5 plus b square equals to 5 square, that is 25, plus b square, plus 2 times 5b, that is 10b. Okay, so here 25b square over 5 is 5b square, 25 over 5 is 5, and 50b over 5 is 10b. In the other side of the equation we have 25 plus 25, that is 50, plus b square plus 10b. Here we have 10b on both sides of the equation, so 10b will get cancelled. After we cancel 10b, in this side of the equation we left only with 5b square plus 5. On the other side of the equation we left only with 50 plus b square. Here we subtracted b square from this equation, equation number 2, and finally we found out that 5b square minus b square is 4b square, plus 5 equals to 50. Here we subtracted 5 from this equation, and finally we found out that 4b square equals to 50 minus 5 is 45. So 4b square equals to 45. Here we divided this equation, equation number 2, by 4, and finally we found out that b square equals to 45 over 4. So b square equals to 45. We substituted 45 by 2 times 5 over 4. So b equals to, we took a root out of this equation, and finally we found out that b equals to the square root of 9 times 5 over 4. The square root of 9 is 3 and the square root of 4 is 2. So inside the root we left only with 5. In conclusion we found out actually that b equals to 3 times square root of 5 over 2 units. And according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So now we can substitute b in this equation, equation number 1, by 3 times square root of 5 over 2. We did it, and we found out that according to equation number 1, x equals to 5 times b, and b equals to 3 times square root of 5 over 2, plus 5 over 2 times square root of 5. So here x equals to this expression equals to 5 times 3 is 15, so in total this expression equals to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. So x equals to, here we multiplied 5 by 2 and then we divided by 2 in order to a common factor with this expression. So x equals to 15 times square root of 5 over 2, 5 times 2 is 10, and then we divided by 2, so we change nothing. All divided by 2 times square root of 5. Then we moved 2 times square root of 5 to the denominator here, and we found out that x equals to 15 times square root of 5 plus 10 over 2 times square root of 5. So x equals to 5 to 15 times square root of 5 plus, here we substitute 10 by 2 times square root of 5 times square root of 5 over 2 times 2 is 4, so in total this expression in the denominator we have 4 times square root of 5. Then we took out square root of 5 as a common factor from the numerator from those two expressions. So square root of 5 is a common factor. What is left from 15 times square root of 5 after we took from it square root of 5 is a common factor? What is left is actually 15. What is left from 2 times square root of 5 times square root of 5 after we took from it square root of 5 as a common factor? What is left is actually 2 times square root of 5. All divided by 4 times square root of 5. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out actually that x, that is the radius that we are looking for, the radius of the semicircle x equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8680 units. Okay, thank you very much.